Have you ever wondered why atoms and molecules behave the way they do? How do they know to combine in just the right amounts to create the substances we see around us? To answer these questions, we turn to the laws of chemical composition. Our first stop is the law of conservation of mass, brought to us by Lavoisier in 1774. It tells us that the total mass of materials after a chemical reaction is the same as before the reaction. So, if you had a bunch of hydrogen and oxygen and turned it into water, the mass of the water would equal the mass of the hydrogen and oxygen you started with. Mass, it seems, is a stickler for consistency. It refuses to be created or destroyed in a chemical reaction. Next up, we have the law of definite proportions. This law, proposed by Proust and tested by Stars and Richards, asserts that elements always combine in a fixed ratio of their weights. This means that a chemical compound will always contain the same elements combined in the exact same ratio by mass, no matter how you prepare it. For instance, pure water will always contain a 1:8 weight ratio of hydrogen to oxygen. Then we have the law of multiple proportions, courtesy of Dalton. This law states that different weights of an element that combine with a fixed weight of another bear a simple numerical ratio. This explains the formation of more than one compound by two elements. For example, the weight of oxygen that combines with 12 grams of hydrogen in carbon monoxide and carbon dioxide are in the ratio 1:2. The law of reciprocal proportions, also known as the law of equivalent proportions, is up next. Proposed by Richter, it says that the weight of two different elements which are combining with a fixed weight of a third element are also the weights with which they combine with one another, or their multiples or submultiples. This law can be observed in compounds like sodium chloride, sodium hydride, and hydrogen chloride. Finally, we have the law of combining volumes proposed by Gay-Lussac. This law is only applicable for gases. It states that when gases react together, they do so in volumes which bear a simple ratio to one another and to the volume of the product, assuming all measurements are made under the same conditions of temperature and pressure. For instance, in the reaction of nitrogen and hydrogen to form ammonia, the ratio of volumes of nitrogen, hydrogen, and ammonia are in a 1:3:2 ratio. These laws are the pillars of our understanding of chemical reactions. They guide the dance of atoms and molecules, allowing us to predict and manipulate the world at the most fundamental level. And to think all of this complexity arises from the simple, elegant rules that govern the behavior of matter.